IQ points, which we'll see why that's significant later. Like 7. Yeah, we'll come back to Maryland next week when we get back in IQ score. Let's build my flock and answer my question, which is, how was I able to surprise the guy at the desk when I said there's a 1 in 3 chance I got a rooster in my little Happy Meal box? So, flock number 4. 4 birds. We know what the average is going to be already, don't we? How many girls on average? Be brave. 3.6. 3.6. You got it. You got it, Nick. Every time we add a bird, we add 0.9 of a girl. So essentially, each of those little birds on average is 9/10 girl and 1/10 boy. So 4 of them gives you 3.6 girls and 0.4 roosters. It's essentially what you're doing on average. On average. Okay, so that's 3.6 girls per 4 birds. Per 4 birds. So we know what the average. This is interesting. You know what the average is before you even have constructed the distribution. Some of you might be sitting there going, okay, Rule, now I have unrefutable proof you're a total jerk. Because if you can get the average without the distribution, why would you teach us about the distributions first? And here's the answer. The only reason we can get this average so quickly is because it's a special kind of distribution. This is a special kind. This will not fit certain things. This will not, it will fit many things, but it won't fit everything. So for this particular kind, which we're going to summarize momentarily, before we get into Max's analysis. There's a special kind of distribution that this fits, and it's a brilliant idea, and it works brilliantly, but that's why you can get the average so quickly. Has anybody else seen the pattern that you simply take the number of birds in the flock times 0.9 and you get that average? We've been doing it informally all day long. We keep adding 0.9, 0.9, that's single multiplication, times 0.9. Times 9. So essentially that's a quick shortcut for the average if you have this kind of random variable, which we'll talk about what kind it is momentarily. Okay, so anyway, we got x equals number of girls. The chance, did I start the camera recording? I'm sorry, I put it behind you too, Christina. Is she red up there, Tim? Little red REC, awesome, thank you.
Wait a second. Your image is in there. It says, and it says record.
It says REC, that's all you. It's better than I'm not in there.
Everything on the top.
So, all right, how many girls, or how many potential, how many random variable values do we have? Sorry, let me assume. What goes here? Yes, good. Sometimes it's better not to be correct, just be clear. There we go. Boom. So 0 through 4, that's how many girls we can have. Which one should we attack first? Let's go with the pattern. We've been always going for this one first. Good. What is that going to be?
0.9.
It's going to be 9/10 to 0.9, 90% to the 4th power, which ends up being, could you guys give me with the 4 decimals?
6561.
6561? That's the number I ished in my head in the store that night. So as soon as he told me 90%, I did 0.9 times 0.9, which is 0.81. I can't carry that many digits, so I dropped the 1 and called it 0.8. And then I did 0.8 times 0.8, which is 0.64. And then I said that's about 2/3. Which means there's about 2/3 of a chance they're all girls. Which also means there's a 1/3 of a chance it's one of these situations up here, yeah? That's it. That's it. It's not magic. It's not magic at all. It's just comfort with the idea of distribution, which you guys are now developing too. So you go to the feed store, you know when you buy 10 birds, you're going to have a boy in that box, most likely. Most likely. Okay, with me so far? So there's 65%. Want to go with all roosters? This should never happen if you buy 4 birds. That should never happen, yeah? As a matter of fact, if you do go home with those 4 chicks and they grow into 4 roosters, what should you question? What do you question at that point?
The breeder.
You question, well, you question whoever told you it was 0.9.
Yeah.
Now, I'm not saying, or you question Max, maybe he went into the what are the boys called? They're not called bullets. There's a name for the little boys, roosters, I guess. Maybe he went to the rooster bin, which I don't think they have one of those. But suppose he did. It's where the boys are.
Like, called like meat chicken. Like
There's something yeah.
like that.
They get turned into soup very frequently, yes. Because people generally don't want them, they want eggs. And you don't need a rooster to have eggs. You need a rooster to have fertilized eggs and more little babies running around. The girls are going to lay regardless. All right, here's where it gets interesting. Let's build the rest of the distribution, yes? Grab one, 1, 2, or 3. Up to you. 1 it is. So by component, what is 1 going to have in it? 0.9. It's going to have a 0.9. That's the girl. And 3, thanks, Ange. 3.1s So 0.1 cubed and a 0.9, which is a 0.0009. But we know that's not right by itself. Patrick's saying
4.
he's got to go with 4. Why is it 4? Because think about it, you want one of them to be a girl. There's 4 different ways to get a girl in there. You can either have Bertha be the girl, or Marge, or Nancy, or Mary. Notice I'm just mentioning the girls now, I'm not mentioning the boys, because we don't have to. If I've identified one of them as the girl, the other 3 have to be the boys. That's one of the beautiful things about this particular distribution that makes it so nice and neat and clean. So what's that end up being? Is that 0.0036?
Yeah.
Check my math on this, friends.
Yes.
Good. Should you expect that if you buy 4 birds at the store? Would you expect to get a girl and 3 boys? I don't think so. That doesn't look very likely at all. What's up, Madeline? What's that?
I got 3.6 to the -7.
To the -7th?
No. Yeah. So
To the -3rd? Yes.
Yeah.
Just check what you're multiplying again. You may have an extra, I think you have an extra 0 somewhere. I'm guessing you have an extra, you put a 0.09 or a 0.01 here.
Oh, yeah.
Yeah, that's all it is.
Thank you.
It's one of the things that happened to us back there, Christina, with yours. All right, shall we jump down to 3 girls and a boy? I think that's parallel, yes? It's parallel only in the fact that this number is going to be 4. Right, it has to be, correct? Because if you want 3 girls and a boy, you have to pick the boy. There's 4 ways for the single bird to be a boy. The difference is going to be in these numbers. It's going to be 0.9 to the, and then 0.1 to the first. And that is going to be, 30%, 28, 29.
2916.
Say it again, Patrick.
2916.
Thank you. Would you be surprised if after 6 months of growing these birds in that you ended up with a rooster and 3 hens? Would you be surprised? That says you shouldn't be. Because that says roughly 30% of the time that's going to happen. That's pretty frequent. Yeah, that's pretty common, right? That's pretty common. 30%, that's not unusual. 1 in 10,000, wickedly unusual. 36 in 10,000, ridiculously unusual. 65%, not at all. 29%, I mean, yeah, it's half as likely as this, but it's still not unlikely. It's just not as likely. Good. So now we know what has to be here, don't we? 30. What's this, like 5%? I'm not exactly sure.
It's 0.0477.
Oh, thank you. 0.477. Beautiful. We know it has to be there. Can we build it on the left side? And just so you know, this is the last time you'll ever have to do all this out like this. Because we're gonna give you a shortcut to actually knock it out for you.
Yeah, so
Go ahead, Renee.
Each of those squares.
Yep, each one's gotta be squared, right? Each one's gotta be squared. Because you got 2 boys, you got 2 girls.
Right.
What goes there?
6.
Um,
I heard a vote for 6. I heard 2 votes for 6. 2 very confident votes for 6. I got some puzzle books too. If it's 6, let's count it. What should we count? We'll look at the girls, yes? Here are the girls. My hand for the girls. Help me count.
1,
1,
2,
2,
3,
4,
5, 6.
Any others? Already got that one, right?
yeah.
Already got that one?
Yeah.
Already got that one? Let's do a little bit more progressively. I'm going to make Bertha be a girl. Let's count it this way. Let's count it again. We got 6 that time, right?
1, 2, 3.
Okay, so now make Bertha not be the girl.
4, 5,
Okay, don't want to go up there because you already counted that one. And then
6.
that's it. 6 2 ways. I agree with 6. Not the least of the reason which is that 6 makes that work. That's a lame mathematical reason. But it is. It's 6. And I'm going to have, I'm thinking of an idea. The numbers you're getting, these multiplier numbers out here are really, really freaking cool mathematically. Have you ever heard of something called Pascal's triangle in earlier math classes? Usually 1 or 2 people have heard of this wonderful thing called Pascal's triangle. I'll mention it briefly here, and I'll put a secondary quiz for next week if you guys want to mess around with it. If you look at Pascal's, what you do is it starts with a 1.
Oh, yeah, I know that is. Okay.
And then after the first couple rows, which are 1s, which are kind of boring,
Right.
each successive number is found by adding these 2. So 1 plus 1 is 2, then a 1 on the end.
Oh,
1, 3, 3, 1, 1, 4, 6, 4, 1. And if you look at those numbers real carefully, you'll recognize them from today. We've used every single one of them. Except for the very top one. We didn't use this one because I didn't buy a flock with 0 birds. It was kind of boring, right? So, but you used those, didn't you? All the ones, we didn't bother writing the ones in, but we could have. 1, 1, 1, 1. So you see those coefficients out front? 1, 4, 6, 4, 1. It's that row right there. Previous one, 1, 3, 3, 1. 1, 2, 1. So now you know what the coefficients would be in the next row down if we had bought 5 birds instead of 4. Renee, ask me that question.
Then how do you get it without counting?
How do you do? Say it again. Say that again.
How do you?
How do we get the next row?
Well, yeah.
So Renee's got an awesome question. This is fantastic. It's awesome. Suppose you have a flock of 20 birds. You'd have to figure out what the flock of 19 would look like. Or the flock of 18, and then the flock of 17, and the flock of 16. And Katie's like, no, I'm not doing that, and you shouldn't do that. So I have 2 answers for you, Renee. I have 2 answers, if that's okay with you. The first answer is, I can give you an equation that generates all these numbers. Okay. If you want that, I will give it to you, but not in class. I'll give it to you after class. I will happily, there is an equation in your project, or not your project, in your take home for Wednesday or Thursday, whatever day you want to turn it in. The last part of that is entering what are called PDFs into Excel and dragging them down. Those are equations, PDFs. There is a PDF for these guys. But there's also a program I'm about to give you that'll do it for you automatically. So you don't have to worry about that. Don't hold that thought for about 2 minutes. Please, Patrick.
Over here for the 2 girls.
Yeah.
0, 4, 8, 6.
Is it 8-6?
Okay. I've done it a couple of times. I'm pretty sure I put this in right.
Well, we can check it real quick.
Yeah.
I believe it only because that adds to 0. That's 0.
Oh, yeah, so apparently I'm 0 deficient.
Oh, no. It is. It's not that big of a deal. It wouldn't be that off, would it? But this is 0.0081 times 6 is 486. That does.
Off by like that.
Hey, we're golden. Hey, and you know what? It's not going to matter in a second anyway, because of what Renee just asked. It won't. This is the last time you will ever build one of these by hand, because it gets too unwieldy. Suppose you had a flock of 10 birds, or 19 birds, or 15 birds. This gets really unwieldy. It's kind of fun. It's fun like puzzling it out. It's also a total pain in the butt. It's a time sink. So what I'd rather do is generalize what kind of problem this is, and then give you a gift in your TIs that'll help you actually do it. And then we'll practice with that today too. But first, a few terms, if that's okay. Actually, 1 term. I shouldn't say there are a few terms. 1 term. This whole chicken flock thing is the example of what I like to call, and the world likes to call, a binomial random variable. I've been foisting these on you all term without telling you. Just to kind of prep you for this. This is one of the most important kinds of random variable that we have. One of the most, if not, it's probably, I would argue it's the most important for you guys as Americans. Because this is the one that helps you understand the news. Whenever they have polls, presidential approval, congressional approval, a percent in favor of ANWR drilling, the flu rates. Whenever you see a poll that's based on a percentage, it's based on this distribution, which is totally rad. So why is it called binomial? Why do you think it's called binomial, first of all? Bi means 2.
Variables.
Hmm?
Well, it's got 2 different possible variables.
That's each. The random variable values vary with how large a sample it's drawn, but the reason it's bi is because you have first trials, and each trial breaks into 2 components. One or the opposite. One or the opposite. So you're buying chicks. You're buying chicks. Those chicks are either male or they're female. Or if you want to make it even more binomial, make it male or not male. Because I think I told you guys about the email I got from that former student. You know, 1 in 10,000 birds is both. So that's actually trinomial. It is. That's trinomial. And it's a great distribution. I'm going to put it with stat of the day in a couple days. But the thing about that trinomial distribution is it's got more rows than this. But the rows that involve the chick that is both male and female is essentially equal to 0 because it's so rare. I mean, one of the options would be buying 4 chicks that both have male and female parts. But that's 1 in 10,000 to the 4th power, which is what?
A lot.
Ridiculously what? So call it. What would you, if you had to express that as a decimal, 1 in 10,000 to the 4th power, what would you call it? Give me a 4-letter word starting with Z.
0.
It's 0. That's not going to happen. It's 0. The chance of it happening is 0. It's 0.0, however many O's that is with a 1, but it's essentially 0. So anyway, that's a trinomial, which is fun. We'll deal with those in Math 244, those of you joining us for that journey. But for binomial, you've got 2 outcomes. outcomes, mutually exclusive. Mutually exclusive. I'll have this PowerPoint posted for you too if you guys don't want all this stuff down. I'll have all this coming to you. So you've got a fixed number of trials. In this case, max, go buy 4 birds. I didn't say max, go fill the bin. Or max, go buy as many as you want. I made that mistake. Buy as many as you want. Shit, I'm back. So I said, go in and buy 4. Why 4? You might know why 4? This is not a math question.
Isn't there an ordinance?
Yep, there's a Bend ordinance that says you can't have more than 4 chickens in city limits on a third of an acre or more. My HOA says I can't have any, but I found a workaround for that one too. So, okay, so what does mutually exclusive mean? Remember that? Remember this phrase means from way back in the day? I also call it a disjoint. Oh, say it again, say it again.
Either one or the other.
Shelby, thank you. It's either one or the other. It cannot be both. So, now, according to my student, it can be. It can be boy and girl. But we're going to make it binomial. Just ignore that case. That's totally fine. So, either a boy or a girl. Either a boy or a girl. Thank you. And last but not least, and I'm not even sure if we need to have this statement. Maybe we do. Maybe we do. I'm not sure. But constant complementary probabilities. This kind of says the same things as 1 and 2, but in a different way. The fact that they're constant probabilities just reaffirms the fact that you have independent trials. Now, of course, we told ourselves that they weren't independent, literally, because Max wasn't putting the chicks back each time. But we agreed that we could treat them as independent, yeah, and I think it's fair. I think it's fair, because you're drawing only a small number. Now, suppose you went into the store. Suppose you went into the store, and you bought half of the chicks they had in the store. You're starting up a huge farm, and you bought half the chicks. Could you make that assumption then? No, because once you start taking more than, say, 50 or 60 of those birds, you're taking a large chunk of that population away, and that 90% won't be 90% anymore. It's gonna, you're pretty much, you have roosters with certainty at that point. With certainty at that point. Is that fair? Please, Katie.
I sent you an email and you told me to remind you, because it's not.
92%.
No.
No.
2%.
2% boys.
Yeah.
98. So Katie had a, hold that thought for 2 more minutes.
Okay.
Thank you, thank you. Katie has some inside information that their breeders get 98% accuracy on the female identification, not 90. And we can see how that would change things. But I don't want to do it manually, no. Because that means you have to redo all of this again. No, we're not doing that. No, exactly, you're all shaking your heads. No. What I want to do is, I want to show you a gift that I made for you guys. Now we're going to take a little bit of time here and share, and then regroup. You don't have this yet, but what we'll do is we'll take some time and show you how it works. So, the gift I gave you is a program. Let me turn this off. Oops. So, once you have this, and I'll give it to you in a second, we'll do this again, but I want to show you what it does. It's under programs, it's called Dist Fill. And what it does is, it builds distributions for you. So everything we just did at the board, it will do for you automatically. So suppose you're building my flocks distribution. So it asks you, what is your smallest x value in your distribution? It's going to be 0. And then it's going to ask you, what's the largest? It's going to be 4. And then it thinks for a second, and it says, okay, what should I put in the next list? In L2. And it's going to be a binomial. I gave you some other options here to mess around with if you'd like, but we're going to mostly use this for binomial. Okay, and then it asks, okay, if it's binomial, it has to have a probability, right? So what probability should I use? 0.9 for chicks, for the girls' chicks. Then it thinks for a couple seconds, it says done. And that's pretty low-fi, but the interesting thing is when you press stat edit and go in there, then you actually have that distribution that we just spent 15 minutes building. So it does it all for you. It builds the entire thing for you from scratch. So you don't have to go through, is it 4, is it 6, is it 8, is it 12, is it 15? It takes care of all that for you. It does the code for it automatically. Kill me because I didn't use it to you earlier. But I wanted you to see the underlying workings before we just gave this to you. The beauty of it is when you have to run it again now. Just fill. When you have a large flock, so suppose you have 20 birds. So 0 through 20, right? It's got to take a little bit longer. Binomial, still 0.9. We'll come back to your 98% in a second, Katie, once I give everything to you guys. Okay, it takes a little bit longer because it's still in L2 right now, but see what just happened? It's done already. We'd still be working on the first one, right? 0.9 to the 20th power to figure out what the hell that is. But you're already done. So you can look right away, and this is what I care about anyway. I would ask you a question like, okay, so if you bought 20 birds, how many roosters would you accept in that little box before you thought something was up with their sexing? So this gives you an idea. If you've got no girls, that means it's all boys. I would think something's wrong there. These numbers essentially are 0, aren't they? They're all very, very small, 0.00000, okay? But then they get bigger because as you're moving down the distribution, you're getting more girls now. Fewer boys, more girls. Now you've got 11 girls. 11 girls and 9 boys. Well, 11 girls and 9 boys is almost 50-50. You wouldn't expect 50-50 if it should be 90-10, right? And that's indicated by a pretty small probability. It's 0.00005. That's pretty small, yeah? How about 12 girls and 8 boys? Would you expect that? Still, I wouldn't expect it. It's getting more likely, yes, but it's still on the low side. When does it start getting in your guys' put some crap on the screen? When does it start getting to the point where you're like, okay, I could accept that many roosters? You guys tell me. Where up here did it switch? 17. Look at that. 19% of the time, you should be getting 17 girls and 3 boys. So if you've got 3 roosters in a pack of 20, no fair complaining. Because that's going to happen roughly 1 in 5 times. Even this, even 16 and 4. That's almost 9%. That's 1 in 11 times. That's pretty common. This is getting borderline. This is getting arguable, borderline arguable. But all these guys down here, now look, check this out. The most likely outcome is 18 girls and 2 boys. Why does that make sense?
Because it's a 90% chance and 90%
of 20 is 18. You would expect 18 girls if you bought 20 roosters because 90% of them should be girls. So you'd expect 2 roosters. As a matter of fact, it's getting pretty hard to get all girls anymore. Look at that. It's only going to happen 12% of the time, 1 in 8. So if I set max in 8 successive years and had to buy 20 hens each time, or 20 pullets each time, on average, only one of those is going to come back all girls. You're going to have a much better chance. There's an 88% chance now that you're going to get some roosters in there. That's almost a guarantee, isn't it? It's almost a guarantee. Isn't that cool? Pretty rad. Now what's cool about this is, Katie, we're gonna pause here and give this to you guys so you have everything. Katie, we can analyze your 98% and see how it affects your overall results. But we'll get you the program first. Let's do that.